I'm calling this video Introduction to Logarithms Day 2. There's a few more ideas to introduce logarithms I thought we should talk about. And so here's a second video that adds a few more pieces to an introduction to logarithms. We'll talk about the graphs of logarithmic functions and also how to compute any logarithm on a TI-84 calculator or even an app that is currently available for iPhones and maybe even other devices as well. Okay, let's get started. Let's graph the following inverse functions. So 2 to the x and log base 2 of x are actually inverse functions. And I think that's a new word for us. And so I will talk about what that means once we graph them and see kind of what happens with these two functions and how they're related. But notice at the very beginning that you have a base 2 of the exponential function and it's log base 2, and those being the same is why we get this pattern of these inverse functions. Okay, so I'm starting with the exponential 2 to the x. So I'll start with zeros. 2 to the 0th power is 1. 2 to the first power is 2. 2 squared is 4, and 2 to the third power is 8. Okay, going negative, the negative will flip over the fraction, and then I can use other exponents. So 2 to the negative first is 1/2, or 0.5 if you prefer decimals. 2 to the negative 2 is 1/4, or 0.25 if you prefer decimals. Okay, now graphing that, I'm over here, and the x-coordinate is -2, the y-coordinate is 1/4, or 0.25, it's there-ish. Okay, at -1, we're at half, so it's kind of at a half. At 0, we are at 1, so I'm here. And at 1, I'm at 2. At 2, I'm at 4. And at 3, I'm at 8. And after that, actually goes off the graph, so I can't really go much beyond that. I can go to the left, actually. If I can draw this down. Now, we've talked before about it being an asymptote. It gets super, super, super close to the x-axis, but never actually reaches the x-axis. And so the x-axis, the negative x-axis, is an asymptote. Okay, that's the graph of 2 to the x. We've seen that before. Okay, the new piece for us is this log base 2 of x. Okay, and I'll start with 1. So the log base 2 of 1 is 0. That's that 0 rule we talked about in the last video. Log base 2 of 2 is 1. That's the identity rule we talked about in the last video. Log base 2 of 4 is 2 to what power is 4? That's going to be 2. And log base 2 of 8 is 2 to what power is 8? That's the third power. Okay, I can go backwards as well. 2 to what power is 0.5, or 1/2? And 2 to the negative first power is 1/2. And then log base 2 of 0.25, or 1/4, is 2 to what power is 1/4? It's a -2. The negative will flip it over, and the 2 will square it, so I get 4 instead of 2. Okay, so notice, let me just pause right here before I graph it. Notice that the numbers I get here, I also got here. Okay, and the numbers that I get here, I also get here. Okay, and this is not mine, that's just for me to kind of think it through. Okay, that is exactly what's meant by the inverse functions. Okay, if you're switching your x, your inputs and your outputs, your x and your f of x or your y, if you're switching those, you get inverse functions. And you learn a whole lot more about that in pre-calculus and beyond. But we have inverse functions, so I at least want to mention that here. Okay, now I'm going to graph this log base 2 of x. This is the first time we're graphing a logarithmic function. Okay, now the x-coordinate of 0.25 is kind of tricky. I'll do my best, and it's at -2 on the y-axis, so like right here. Okay, and at 0.5, I'm at -1. Okay, and at 1, I'm at 0. At 2, I'm at 1. At 4, I kind of skip over 3. At 4, I'm at 2. At 8, I'm at 3. Okay, so the graph actually comes down like this. Okay, now one thing to kind of talk about a little bit, I should have gotten closer sooner, is that the logarithm for the exact same reason that we have an asymptote at the negative x-axis for the exponential is the exact same reason that we actually get an asymptote down here at the negative y-axis. Okay, you actually can't plug in, we actually can't have the log of any base of 0, okay, because there's no number I can raise the base to that would give me 0. Okay, you can't do that. That's not equal to anything. Okay. Similarly, you can't plug in negative numbers if your base is positive, which they almost always are. You can't plug in a negative number. Okay, because the positive base, like base 2, for example, the positive base, there's no power I can raise it to that makes it negative. Okay, negative exponents give me fractions or 1 over something, but I can never get a negative number. So the domain of my logarithmic function is the positive x-axis. Okay, it's greater than 0. Okay, so let's just talk about that. Now, back to our inverse function conversation. The inverse function, graphically what happens, because it's sitting right here, is it's a reflection over the line y equals x. Okay, because you're kind of switching x's and y's. It's a reflection over the line y equals x. That always happens for all inverses. Okay? Now, that's it for these two graphs. I'm going to show you one more. Not this one. This one's very, very similar to the above. It's just base 3 instead of base 2. Very similar things happen. But on number 3, it's a 1/2 as the base. And so some different things happen here that I think are worth discussing. Okay, I'll start off with the exponent in red again. So 1/2 to the 0th power is 1 because anything to the 0th power is 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4, and 1/2 to the third power is 1/8. Okay, 1/2 to the negative 1, the negative will flip it over, and then I raise it to the first power, which is pretty easy, and you get 2. 1/2 to the negative second power, the negative flips it over, and you square it, so you get 2 squared is 4. Okay, if I go over here, I have negative 2 is at 4. And I have negative 1 is at 2, and at 0 I have 1, and I have 1 is 1/2, and 2 is 1/4. It gets really hard when it gets really small. 3 is 1/8, and so actually I get this function. And it didn't ask me, but I would know it at negative 3 I'm at 8. Just kind of finish that off there. So I have this exponential decay function right there. We've seen that one before, actually. Okay. Now, let's see what happens when you have the log base 1/2 of x. Okay. Now, the log base 1/2 of 1 is 0 because 1/2 to the 0 is 1. Let's go this way actually. Log base 1/2 of 0.5 or log base 1/2 of 1/2 is 1. That's the identity rule. Log base 1/2 of 0.25 is 1/4, so 1/2 squared is 1/4. Okay, going over here, of positive 2. 1/2 to what power is positive 2? Well, if I raise the negative first power, then I actually flip it over, and that gives me a positive 2. Okay, 1/2 to what power is 4? I get negative 2. The negative will flip it over, and then I can square it. 1/2 to what power is 8? It's negative 3. Okay, so let me graph these functions. So at x is 0.25, I have positive 2. At 1/2, I have 1. At 1, I have 0. At 2, I have negative 1. At 4, I have negative 2. And at 8, I have negative 3. Okay, so it actually looks like this. Okay, and so it's also, like I pointed out before, it's also a reflection over the line y equals x. So we do also have inverses here as well, although the order isn't the same. So like if I flip, so this is the same as this, the order is backwards. Okay, which is why this is the same as this. I should change colors just so it's clearer. So I have this is the same as this, the order is backwards. So the way it was kind of ordered doesn't show you the inverses as well, but there are also inverses here too. Okay, and so reflecting it over the line y equals x, it isn't as obvious to see that, but it does work. Okay, and for the same reason you get a decay and having an asymptote for the exponential function in red, the same reason you get that an asymptote at the positive x-axis is why you get an asymptote for the logarithmic at the positive y-axis. Okay, so those are a little bit about graphing logarithmic functions, and a logarithmic base that is positive will look more like the first one, where you kind of starts down asymptotic to the negative y-axis and then grows. And a base that's between 0 and 1 will be asymptotic at the positive y-axis like this one is, and kind of goes down and just is an exponential kind of it's a growth down. The last idea is how to compute any logarithm in your calculator. Okay, now if you look at it, if you have a TI-84 graphing calculator, you'll notice that on the left-hand side near 7 and 4, we have the buttons log and ln, okay, as buttons. Okay, that's log base 10 and the natural log base e. Okay, but many times what we're doing is not base 10 or base e. So what do you do then? Okay, if it's not base 10 or base e, if you push the math button, okay, and then if you scroll down, or actually going up is actually faster, under A, we have log base, is what it says, okay? If you click that, it takes you back to your home screen, and it says log, and there's like an area to put the base, and then a place to put the number it's in there. So you can just type in, let's say 2 of, I don't know, 16. If you base 2 of 16, and it gives you 4, which I already knew that, okay? The power of this, though, is that you can do any number in here. Let's do like 1,000. So 2 to a power is 1,000 is 9.966 approximately, okay? You can do any logarithm on your calculator. Okay, now if you're saying, Mr. Lewis, I don't have a TI-84 at home, they're really expensive, I'd agree with you. There is an app, at least this is recorded in 2021. There's an app, I have an iPhone, but if you have other devices, hopefully there's a similar thing there. If you know of any, put that in the comments below. But it's called Calculator X, and the icon that's used in the App Store says calculator on the left, and the calculator looks like a TI-84, and it says X equals 84 in the kind of screen of the calculator. Okay, it looks very much, I mean, it does 95% of the stuff that TI-84 can do. It can do log base as well. It's the exact same as I just described. You hit the math button, and then under A, it's log base. You can just push log base. It's the exact same. You can type in, base 2. You then kind of click with your finger so that you're putting into the, of number, put 1,000, and boom, you get the exact same thing. Okay, so either TI-84 or the calculator app called Calculator X. Okay, it's a free app. I'm not endorsed by Calculator X, but that's what, if I'm at home and I can't find my TI-84 calculator, I pull that out and use that. It works for almost everything we do in this course. Okay, so that's how you compute any logarithm on your calculator. Now that I've taught you this, please do not use that every single time. If you can think it out in your head, please do. It helps with your understanding of what logarithms are, and if you just, always compute it in the calculator without thinking through it first, then you will kind of forget what it is even talking about, and you won't understand the problems that you're really solving. Okay, this was a second day of an introduction to logarithms. We talked about graphs of logarithmic functions, and we talked about how to compute any logarithm on a TI-84 calculator or using Calculator X app on a phone. Thanks for watching.